Hello and welcome to the next lecture. In this lecture, we will continue talking about the loop functions in R. So let's jump right in it. The apply function is another loop function that's used to evaluate a function over the margins of an array. Usually the function is going to be an anonymous one like we showed with lapply, or it could be a function that already exists like the main, for example. It's usually used to apply a function to the rows or columns of a matrix. Of course, matrices which are two-dimensional arrays are going to be the most common type of array that we are going to use in R. But you may have three-dimensional arrays and such. So you can use apply on general arrays such as taking the average of an array of matrices, for example. One thing to note, and you may hear this out in the wild, that occasionally using apply is somehow better than using a for loop, or somehow it's faster than using a for loop. And that's generally speaking is not true. It was true a long time ago in older versions of the S language, but in R right now it's not true at all. The main reason you want to use a function like apply is that it involves less typing, and less typing is always better because good programmers are always lazy. So apply is very useful, but in particular on the command line, because on the command line when we are interacting with data, we are doing exploratory analysis. We want to do as little typing as possible because it just makes our fingers tired. Well, how does apply work? So the first argument acts as an array. An array is a vector that has dimensions attached to it. So a matrix is a two-dimensional array. A margin, this is a vector, an integer vector that indicates which margin should be retained. And the last important argument is the function that you want to apply to each of the margins. And then the dot 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 argument are other arguments that you want to pass and include other arguments that you want to pass to the function. So here's a matrix that I'm creating. It has 20 rows and 10 columns. So in the matrix, it's just normal random variables that I have generated. So when I apply, so what I want to do is I want to take this matrix and I want to calculate the mean of each column of the matrix. So the way I can do this is I can use the apply function on X. It gives me the margin 2. Now I'll tell you what that means in a second, and I pass the function mean, and so what happens is I get back a vector of length 10 that has the mean of each of the column of the matrix. And so the idea is that it has 20 rows and 10 columns, and so that you can think of matrix as dimension 1 has 20 rows and the dimension 2 has 10 columns. So when you apply the function mean over the matrix, well, the idea is that you want to keep the second dimension, which is the number of columns, and you want to collapse the first dimension, which is the rows. So the idea is that you are taking the mean across all the rows in each column, and then you are essentially limiting the rows from the array. So what you get back is actually has one of the dimensions has been eliminated. It's really the first dimension that's been eliminated, and so you get this number, I mean vector, which has each of the means for each of the columns. Similarly, you can take the means of all the rows of the array and I can call the apply function on X. I give it the margin 1, which means preserve all the rows but collapse all the columns. And then here I am calculating the sum of each row instead of the mean. So I cast the 1 because it says I want to preserve the rows and collapse the columns. So here I got a vector of 20 because there's 20 rows, and for each row I calculate the sum of that row. Now for simple operations like calculating the sum or calculating the mean of a column or of a row, there are special functions that are highly optimized to do this very quickly. So for calculating the row sums and row means, there's the functions row sums and row means. And similarly, there's call sums and call means which do the same thing for the columns. These are equivalent to using the apply function, but they are very much faster than using the apply because they are optimized specifically to do those operations. So if you want to calculate the sum or the mean of the column or a row of a matrix, use those functions instead. Now you can, use the apply function to apply other types of functions. For example, suppose you have a matrix. Here I've again generated a matrix of random normal variables that's 20 rows by 10 columns. And suppose I want to go through each row of the matrix and calculate the 25th and the 75th percentile of that row. So I can apply on X. I pass the margin of 1 because it means I want to preserve the rows, and then I'm going to pass it the quantile function. Now the quantile function needs the quantiles that you want to calculate. So there's no default value for that. So I actually have to pass it to the quantile function through the dot 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 argument of apply. So here the argument for quantile is called props, and I give it 0.25 and 0.75, meaning I want to calculate the 25th percentile and the 75th percentile. So what this call does is it goes through each row of the matrix, and for each row it calculates the 25th and the 75th percentile. So for each row there's going to be two numbers that are returned, and what apply will do is it will create a matrix that has two rows, and the number of columns is equal to the number of rows in this matrix, which happens to be 20. So here I'm going to get a 2 by 20 matrix, where in each column of this return matrix I've got the 25th and the 75th percentile for the corresponding row. So for example, for the first row the 25th percentile is minus 0.33 and the 75th percentile is 0.92. And for the 16th row, the 25th percentile is minus 0.95 and the 75th percentile is 0.88. So you can see how that works. Now suppose I had more than just a matrix. Suppose I had an array that I want to do something with. So here I am creating an array which has normal random variables, and it has two rows and two columns, and the third dimension is 10. I guess I'm not sure what you would call that dimension, but you can imagine this, you can think of this as being there a bunch of 2 by 2 matrices that are kind of stacked together. And the idea is that you can imagine I have a bunch of 2 by 2 matrices, and I want to take the average of those 2 by 2 matrices. So the average of the bunch of 2 by 2 matrices is going to be another 2 by 2 matrix, which is the mean, and so I can call apply on this array. And I want to keep the first and the second dimension, but I want to collapse the third dimension. So here when I give the margin, I give it 1 and 2, which I want to preserve, and then 3 is not there, which means I want to collapse third dimension. And then the function I pass it is the mean. So what this will do is it will take my array and it will collapse and average over the third dimension and give me the mean matrix. Another way that you can do this is to use the row means function. So even though this is in a matrix, you can apply row means to an array and you pass the argument dims equal to 2, and this will return the same thing. Next, the mapply is a loop function that is a multivariate version of the lapply and sapply functions that you have seen previously. And the idea is that it applies a function in parallel over a set of different arguments. So one thing we have noticed about the previous functions lapply and sapply is that they only apply a function over the elements of a single object. So for example, if you think about lapply, the input to lapply was a list, a single list, that's it. And then the function was applied over the elements of that list. So what happens if you have two lists that you want to apply a function over, and suppose you have two lists and the elements of the first list go into one argument of the function and the elements of the second list go into the another argument of the function. So lapply and sapply can't really be used for that purpose. So one way to do that is just to write a for loop, where the for loop will index the elements of each of the different lists, and then you can pass a function to each of those elements of the list. Another way to do that though is with mapply, where mapply can take multiple list arguments and then apply a function to the elements of those multiple lists in parallel. So the function arguments for mapply are a little bit different, just because it has to allow for the possibility of a variable number of arguments. So here the first argument to mapply is the function that you want to apply, and the function that you are going to pass to mapply has to have the number of arguments that the function takes has to be at least as many as the number of lists that you are going to pass to mapply. So the list or the things that will be coerced to a list will be passed through the dot 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 argument. And so if you have three lists, you will pass three objects, and then your function has to take at least 3 arguments to it. So the more args argument is just if you have more arguments and you need to pass to your function, and the simplified argument is similar to the simplified arguments that you saw in sapply. So here for example I'm creating a list here, and the list has I'm going to repeat 1 4 times, the integer 1 4 times, I'm going to repeat 2 3 times, I'm going to repeat 3 2 times, and repeat 4 just once. So it's a little bit tedious to have to type something to do, even though this is a fairly artificial example, But with mapply it's actually quite simple. I can just do mapply rep. So rep is the repeat function, and then repeat it has two arguments. So the first set of arguments is going to be 1 through 4, and the second set of arguments is going to be 4 through 1. And you can see that in list above here, the first argument was 1, 2, 3 and 4, and the second argument was 4, 3, 2 and 1. So those are the two sets of arguments that I'm going to pass to mapply, and you can see that when I do that, I get my list of 4 1s, 3 2s, 2 3s and 1 4, just like the list that I have above here. So mapply can be used to apply a function to multiple sets of arguments. So here's just another very simple function. It just generates some random normal noise, and the function has 3 arguments: the number of observations, the value of the mean and the value of the standard deviation. So if I just apply noise to with a single set of arguments 5, 1 and 2, I get 5 random normal variables with the mean 1 and standard deviation 2. However, this function doesn't work really correctly if I pass it a vector of arguments. So now what's happening is I get a vector of 5 here when I pass it 1 through 5 and 1 through 5. But really what I want to happen is to have 1 random normal with mean 1, 2 random normals with mean 2, 3 random normals with mean 3, etc. and then 5 random normals with mean 5. And so that's what I get here when I use the mapply function. And if I vectorize this noise function, I give it 3 sets of arguments. So it's 1 through 5, 1 through 5 and then 2. So I'm always going to fix the standard deviation to be 2, but I'm going to be changing the n, and I'm going to be changing the mean. So now I have got one random variable with the mean 1, I got 2 with mean 2, 3 with mean 3, 4 with mean 4 and then 5 with mean 5. So that's how I can instantly vectorize a function that doesn't allow for vector arguments. So this is the same as I were to manually type out a list with these 5 different function calls. So this way it's nice to be able to instantly kind of create a function that doesn't allow for vector inputs and to kind of instantly vectorize it. So that's it for today. See you in the next lecture where we will keep discussing other loop functions. So till then, read the material that is provided to you in the blog post and in the book, and practice what I give to you, because let alone watching these lectures won't make you a programmer. You will have to practice to become a good programmer. And if you like my videos, then do share them and hit the like button and subscribe our channel so you don't miss on latest lectures. So see you in the next lecture. Ciao.